Hey everyone, and welcome back for another deep dive. Today we are taking a look at a fascinating recent discovery that has scientists really excited.
It's really changing how we think about carbon compounds, the building blocks of everything we know,
That's right.
how they form and survive in space.
Yeah, and our sources today are a Science Journal article and a news piece from SciTech Daily.
Both are about a molecule called pyrene and its potential role in how our solar system formed.
So think about it.
The vastness of space filled with these clouds of dust and gas
Right.
that eventually become stars and planets.
Well, it turns out this complex carbon molecule, something you might even find on like char marks on grilled food,
Yeah,
could be a key ingredient in that recipe.
it's really quite amazing.
So let's get started. First,
Let's set the scene.
okay.
Picture this distant interstellar cloud
Right.
called TMC1.
Okay.
It's incredibly cold, only 10 Kelvin.
Wow.
And it's very similar in composition to the cloud that created our solar system.
Oh, wow.
So TMC1 is like a cosmic time capsule.
Yeah.
Oh, that's interesting.
Letting us peek into the processes that led to our corner of the universe.
That's pretty cool.
That's like having a front row seat to the very beginning.
Okay, so that is where pyrene comes in.
Right.
It's this polycyclic aromatic hydrocarbon, or PAH, composed of 4 fused carbon rings.
Yes.
Now, to give you a more tangible idea,
Yeah.
you'd find pyrene in the char marks on grilled food
It's true.
here on Earth.
For a long time, scientists have suspected PAHs play a big role in the interstellar medium, but detecting them directly has always been a challenge.
Okay.
Pyrene itself is basically invisible to traditional radio astronomy methods.
Invisible. Why is that?
It's because of its symmetrical structure.
Okay.
It makes it radio silent.
Huh, interesting.
So pyrene's electrons are evenly distributed.
Okay.
It's like trying to track a stealth bomber, you know. It's designed to be invisible to radar.
Ah, gotcha. And pyrene is kind of similar.
So it's hidden from our telescopes.
Right.
Okay, but how did these researchers find it if it is so hard to detect? That's where their ingenuity comes in.
All right.
They decided to detect a modified version of pyrene called cyanopyrene.
Okay.
It has a cyanide group attached,
Uh-huh.
and that disrupts the symmetry, making it detectable by our radio telescopes.
So they basically tagged it,
Exactly.
made it visible.
Exactly.
Okay.
And they used the Green Bank telescope and found cyanopyrene in TMC1.
Wow.
But here's the amazing part.
Okay.
Pyrene accounts for 0.1% of all the carbon in that cloud.
Really?
Almost 0.1% of all the carbon
Wow, that's a lot.
in this huge cloud
Yeah.
is locked up in this one molecule.
Wow. That is a huge amount, especially when you think about all the different carbon-containing molecules out there.
It is.
It's like finding a massive diamond
Yes.
in a pile of pebbles.
Exactly.
Wow.
And remember those samples recently returned from asteroid Ryugu?
Oh, yeah, by the Hayabusa 2 mission.
Yes.
Yeah.
They found large amounts of pyrene there too.
Wait, so this molecule is in a distant cloud and in asteroids in our solar system.
Right.
What are the odds?
That's what researchers are thinking about.
Yeah.
Since TMC1 is similar to the cloud that formed our solar system,
Right.
and we see pyrene in both TMC1 and in asteroid Ryugu,
Yeah.
it's starting to paint a picture.
It's like we are following these cosmic breadcrumbs,
Yeah.
leading us to believe that pyrene might have been a major source of carbon in our solar system.
Yeah, and Professor Brett McGuire from MIT sums it up perfectly when he said,
Yeah.
we now have the strongest evidence ever of this direct molecular inheritance from the cold cloud all the way through to the actual rocks in the solar system.
Wow. That is quite a statement.
It is.
It makes you think about the journey this pyrene molecule took
Right.
from the cold clouds of space to
Isha.
potentially becoming part of planets.
It is amazing.
Really puts things into perspective.
It does.
It makes you wonder, though, where did all this pyrene even come from?
That's the question.
We've got this molecule in a distant cloud and an asteroid,
Right.
potentially key to forming planets. But where did it come from?
There are two main ideas.
Okay.
One is that pyrene formed within the cold cloud itself,
Okay.
maybe through a series of chemical reactions on the surfaces of dust grains.
Okay.
The other is that it came from somewhere else,
Right.
perhaps from dying stars.
So either born in the cold depth of space or came from dying stars.
Right.
It's like a cosmic detective story.
It is.
So we've got this pyrene molecule found in a distant cloud, an asteroid, and it could even be key to forming planets.
It's pretty wild.
And we don't even know where it came from.
And that's where we will pick up in the next part.
Yeah, stay tuned, because we will be diving deeper into the world of Pyrene.
And exploring what it can tell us about the origins of our solar system.
Sounds good to me.
It's fascinating stuff.
Yeah, wait.
This discovery wasn't just some simple observation.
That's right. It's not like they could just point a telescope and say, hey, look, it's Pyrene.
Yeah, they had to figure out how to even look for it.
So remind us, how did they actually find it?
So we talked about how Pyrene itself is radio silent.
Yay.
Because of the symmetrical structure.
Yeah.
They had to get a bit creative.
Okay.
And focus on finding that modified version of Pyrene, cyanopyrene.
The one with the cyanide group attached to disrupt the symmetry.
Yes.
Okay, so it makes it detectable by our radio telescopes.
Exactly.
But it wasn't just looking for any signal, was it?
Oh, you got it.
What did they have to do?
Well, they actually had to synthesize cyanopyrene in the lab first.
Wait, so they created it here on Earth first before looking for it in space?
Yeah. So they had to figure out the exact signals emitted by cyanopyrene in a controlled environment.
So they could have a fingerprint for the molecule.
Exactly like a suspect's photo before a manhunt.
Ah, that's a great analogy.
So armed with this fingerprint, they used the Green Bank telescope to scan TMC-1. And there it was.
Wow.
The telltale signs of cyanopyrene.
So it really was there.
Yes, confirming its presence in that cloud.
That is incredible.
And it really challenges our understanding of how carbon compounds form and survive in space.
You mentioned that earlier.
I did.
What did you mean by that?
Well, first of all,
the
amount of pyrene they found in TMC-1 is surprising. It's a lot more than we thought.
Right.
It suggests that complex organic molecules might be a lot more common in the universe than we previously thought.
Wow. That is a lot to consider.
Especially when you think about how cold it is out there.
Yeah, 10 Kelvin, right.
Right.
That's unimaginable.
It is incredibly cold.
Yeah.
And, we used to think those conditions would make it really hard for big, complex molecules to form.
Right. It's like finding a garden.
Yeah.
Blooming in Antarctica.
That's a great analogy.
It just doesn't seem possible.
And it has us rethinking the processes behind forming these complex molecules.
So how did we think they formed before?
The traditional view was that PAHs, like pyrene, formed in the hot outflows of dying stars.
So the theory was that they were created in these explosions. Right.
And then moved to these cold clouds.
Yes, but with so much pyrene in TMC-1, it suggests maybe they can form right in these cold clouds.
Oh, so not from dying stars.
Maybe not. Maybe they form through reactions on the surfaces of dust grains.
So instead of top-down from dying stars to cold clouds, it could be bottom-up.
It could.
Molecules forming in the cold.
Precisely.
That changes everything.
It really does. It opens up a whole new chapter in astrochemistry.
It's like we found a secret factory in space.
A hidden factory making these building blocks of life.
Wow.
In a way we never anticipated.
It's mind-blowing.
It is.
And I keep thinking about that quote from Professor McGuire.
Yeah.
He said, it's an almost unbelievable sink of carbon, an interstellar island of stability.
I like that quote.
It really sums it up.
It does.
It's this molecule surviving in a place we never thought possible.
And it leads to more questions.
Right.
If complex organic molecules like pyrene can form and hang out in these harsh environments,
what does that say about life in the universe?
Oh, wow.
Could life be more widespread than we think?
That is a profound thought.
It is.
Okay, so let's go over what we've learned. We've got this amazing discovery, pyrene.
Yeah.
This simple molecule that we know from grilled food char could actually be essential for making planets.
It could.
But it could even be telling us about the possibility of life beyond Earth.
It really shows how everything in the universe is connected.
It does.
And that even something as familiar as barbecue char can be linked to forming stars and planets.
It all starts with curiosity.
It does.
Observation and just being open to challenging what we think we know.
It is a never-ending journey of discovery.
It really is.
And with every new finding, our understanding of the universe changes.
And our place in it. This has been an incredible deep dive so far.
It has.
But stick with us.
Yeah, there's still more to come.
We're going to be exploring the implications of this discovery.
And all the research it's inspired.
Should be fascinating. You know, it's amazing to think about.
What's that?
The journey of this little pyrene molecule from these vast cold clouds to being part of planets and maybe even life itself.
It really does highlight how everything is connected in the universe.
It does.
Like the atoms that make up our bodies, the Earth, everything we see,
Right.
they were all created in stars
Yeah.
and then spread out across the cosmos.
And to think
Yeah.
we have this evidence that pyrene,
Yeah.
this molecule that forms in these crazy cold conditions,
Right.
could be a key ingredient for making planets.
It could be. It's really fascinating.
It really changes how we view space.
How so?
Well, we think of it as this empty void,
Right.
but really it is this super dynamic and complex chemical laboratory
It really is.
where molecules are constantly forming and reacting and evolving.
That's the beauty of it.
It just makes you wonder what else is out there.
Yeah.
What other simple molecules are hiding these huge cosmic mysteries?
Who knows?
This discovery is just the beginning.
Exactly. It's sparking so much research.
That's great.
As scientists are trying to understand how pyrene forms,
Mm-hmm.
how it survives,
Yeah.
and what ultimately happens to it.
Yeah, it's like opening a door in a huge mansion.
Yeah.
We see this one fascinating room,
Uh-huh.
but there's so many others we haven't even discovered yet.
I like that analogy.
And that is what is so exciting.
It is.
Researchers are planning to use these super powerful telescopes
Oh, wow.
to search for even larger PAH
Wow.
in TMC-1 and other interstellar clouds.
That's going to be amazing.
Imagine the possibilities
Lion
if we are surprised by how much pyrene there is,
Right.
a 4-ring molecule.
Yeah.
What happens when we find 5, 6, 7-ring molecules?
I can't even imagine.
And it's not even just finding them.
Right.
It's understanding what their role is,
Right.
like how they help form stars and planets and even life itself.
It's incredible.
And who would have thought?
What's it?
That something as simple as char marks on our barbecue
Yeah.
could hold clues to the origins of the universe.
It really shows how science can connect those everyday things.
It does.
These huge, extraordinary concepts.
Yeah.
It really shows how even the smallest things can reveal the biggest truths.
So why should anyone listening care about this molecule found in some distant cloud of gas and dust?
I think it reminds us that we are all part of something bigger.
We are.
You know, the atoms in our body,
Yeah.
the air we breathe, the
Yeah.
earth,
Yeah.
they all came from the same place, stars.
And this pyrene discovery just shows us that these building blocks of life can
Yeah.
form in the most unexpected places.
Exactly.
It really makes you think about how much potential for life is out there.
It really does.
This deep dive into pyrene has been amazing.
It has.
I hope everyone listening feels the same way.
Me too.
We've learned so much.
We have.
And I hope it's made everyone a little more curious about space.
It's a vast universe out there,
It is.
just waiting to be explored.
So until next time,
Yeah.
keep looking up
Keep asking questions.
and never stop exploring.